For decades, the propeller aircraft reigned supreme as the undisputed master of the skies. The roar of the piston engine and the blur of spinning blades defined aerial combat and bomber raids across 2 world wars. By the mid-1940s, however, the limits of piston technology were becoming painfully clear to engineers on all sides. Faster speeds meant heavier engines, thicker wings, and complex, high-maintenance supercharging systems. Every increase in performance came at a steep cost in fuel consumption and mechanical reliability for the airframes. A quiet revolution was brewing in secret laboratories, fueled by the relentless pursuit of speed. This new concept promised an entirely new form of power, pure jet propulsion, stripping away the need for bulky propellers and their inherent drag. Germany, facing total defeat and desperate for a war-winning edge, channeled its remaining resources into this nascent, game-changing technology. The focus shifted rapidly from fighters to bombers, seeking a platform that could strike and escape before any enemy aircraft could even react. This radical shift in design would ultimately shatter the prevailing wisdom about aerial warfare forever. The Allies, with their vast fleets of conventional bombers, initially dismissed these experimental German designs as desperate folly. They viewed the new jets as little more than unreliable, expensive curiosities with no real strategic value. Allied intelligence reports regarding Germany's jet programs were often met with skepticism and a profound lack of urgency. The sheer scale of Allied air superiority made it easy to ignore the faint whispers of a revolutionary threat. Pilots of Spitfires and Mustangs had grown accustomed to chasing down and dispatching slower, prop-driven targets with relative ease. They saw the German jet concepts, particularly the idea of a jet bomber, as impractical and far too early for operational use. The Allies possessed a deeply ingrained belief in the effectiveness of their heavy bomber formations, protected by long-range escort fighters. They reasoned that any new German technology would be too limited in number to pose a meaningful threat to the crushing volume of the Allied air campaign. Their confidence was buoyed by the consistent, overwhelming success of operations like the bombing of the Ruhr and the advance into Germany. This complacency led to a critical underestimation of the speed and potential of early jet aircraft development. The focus remained firmly fixed on piston-powered excellence, optimizing designs that were already reaching their physical limits. This failure to grasp the coming paradigm shift would soon be violently corrected by a single, sleek, twin-engine aircraft. The Arado R-234 was quietly preparing to demonstrate a speed advantage that negated every tenet of Allied air defense doctrine. Its existence served as a silent warning that the rules of engagement were about to be rewritten in the skies above Europe. By 1943, the situation for the Third Reich was becoming dire, both strategically and industrially. The relentless Allied bombing campaign was systematically dismantling Germany's ability to wage war, striking deep into its manufacturing heartland. Luftwaffe commanders recognized their existing reconnaissance and bomber fleets were too slow and vulnerable to operate effectively over contested airspace. Standard piston-engine aircraft were easy prey for the growing numbers of Allied fighters that patrolled the skies. A desperate need emerged for an aircraft that could fly missions with impunity, gathering vital intelligence and delivering precision payloads. The requirement was simple: an aircraft that could enter enemy territory, complete its task, and return home without ever being intercepted. This imperative led to an extreme focus on speed, making jet propulsion the only viable option for the role. The Reichswehr Ministry, or RLM, accelerated various jet projects, hoping a miracle weapon could reverse the course of the war. The Arado company, leveraging their expertise, proposed the A-234, an aircraft originally conceived as a simple, high-speed reconnaissance platform. It was envisioned as a flying camera that could streak past any existing Allied fighter without engaging in combat. The strategic value of invulnerable reconnaissance was immense for a high command starved of accurate, real-time intelligence. This urgent necessity for survival was the true catalyst for the rapid, if compromised, development of the world's first jet bomber. The design philosophy behind the Arado A-234 was radical in its elegance and simplicity. Unlike the contemporary Messerschmitt Me-262 jet fighter, the A-234 adopted a clean, streamlined, high-wing monoplane configuration. Its airframe was deliberately kept as lightweight and aerodynamically efficient as possible to maximize the available thrust from the early engines. The lack of bulky propeller assemblies allowed for a perfectly laminar airflow over the wings, dramatically reducing drag. The cockpit was an iconic glass bubble, providing the single pilot with exceptional visibility in all directions. Initially, the design featured an innovative, yet impractical, system of a jettisonable three-wheeled trolley for takeoff and landing on skid plates. This trolley design was intended to save weight and complexity but proved cumbersome and restrictive in operational use. Later variants of the aircraft incorporated a conventional tricycle landing gear, known as the A-234BU Blitz, which became the operational standard. It was powered by a pair of reliable, though still temperamental, Junkers Jumo 004B turbojet engines mounted under the wings. The jet engines offered a massive leap in power-to-weight ratio compared to any piston engine of the time. This combination of minimalist structure and raw jet power created an aircraft capable of speeds that defied contemporary aviation standards. The A-234 was a pure manifestation of speed, designed with a single-minded purpose: to fly past everything. The transition from a pure reconnaissance plane to a bomber was a pragmatic, if desperate, choice driven by military necessity. The RLM realized that an aircraft capable of evading all interception was also the perfect platform for delivering ordnance. By sacrificing some of its range, the A-234 could carry a surprisingly useful payload of up to 1,500 kilograms of bombs. This made it a fast, tactical bomber, though it lacked the heavy payload capacity of Allied four-engine heavies. The first successful test flight of the A-234 prototype, the V-1, occurred in the summer of 1943. The maiden flight immediately confirmed the aircraft's revolutionary performance and its massive potential for high-speed evasion. The sight of the sleek jet taking to the air without the characteristic thrum of propellers was a moment of true aviation history. Development was continually plagued by engine issues, material shortages, and the constant threat of Allied bombing raids on the production facilities. Despite these critical wartime constraints, the program pushed forward with extraordinary focus and determination. The operational debut finally occurred in the latter half of 1944, a time when the Allies believed they had total control of the skies. Its arrival marked the first time the world had seen a jet-powered aircraft deployed in a dedicated bombing role. The jet bomber's birth was not a glorious moment of triumph, but a quiet, efficient answer to Germany's escalating defensive crisis. For much of the war, the Allies held an overwhelming advantage in aerial reconnaissance over Europe. Their specialized photo reconnaissance units flew converted fighters and medium bombers that were typically stripped of armament for better performance. Aircraft like the unarmed de Havilland Mosquito PR Mk-16 could fly fast and high, but they were still vulnerable to interception. The Allies used these platforms to meticulously map German defenses, troop movements, and industrial targets. The entire planning process for strategic bombing and ground invasions was dependent on the steady flow of photographic intelligence. However, even the fastest Allied reconnaissance planes had to operate with great caution, knowing a determined interception could lead to their loss. German radar and fighter control systems, though stressed, still posed a credible threat to the Allied recce missions. The intelligence gathered was often delayed, taking hours or even days to process, which reduced its value on the rapidly shifting front lines. The entire Allied strategy rested upon the assumption that they possessed the fastest, highest-flying aircraft available for this critical task. This perception of unassailable dominance was a deeply held conviction that the Ar-234 was designed to utterly dismantle. It aimed to show that reconnaissance could be performed not just quickly, but with absolute immunity from attack. The age of vulnerable, prop-driven observation aircraft was quickly drawing to a close, a fact the Allies were about to learn firsthand. The Arado Ar-234 entered service not as a frontline bomber, but initially as the ultimate photographic reconnaissance tool. Its speed was its shield, and its altitude capability was its protective armor against conventional threats. Flying at speeds of over 740 km per hour, it was often 100 to 200 km per hour faster than the fastest piston-engine fighters of the time. Allied pilots attempting to intercept the sleek jet found it an exercise in total futility. The German crews could simply maintain maximum speed and watch as the pursuing fighters fell hopelessly behind. This absolute speed difference meant the Ar-234 could fly virtually anywhere over Allied-held territory and return completely unscratched. The jet carried two RB-50/30ths or RB-75/30ths cameras mounted side by side in the aft fuselage, pointed straight down. These cameras, combined with the jet's stable, high-altitude platform, delivered exceptionally clear and current aerial intelligence. This real-time, invulnerable reconnaissance proved to be its most effective and terrifying capability during its brief service. The jet's quick turnaround time allowed intelligence reports to be generated rapidly, providing German command with fresher data. For the first time, a German aircraft could systematically monitor the Allied advance with no risk of being shot down. The Ar-234 demonstrated that blinding speed and photographic clarity were the future of aerial intelligence gathering. One of the most defining and dramatic operational chapters for the Arado Ar-234 involved the Ludendorff Bridge at Remagen. In March 1945, the unexpected capture of this vital bridge over the Rhine River gave the Allies their first crucial foothold in Germany. The German High Command was instantly desperate to understand the full extent of the Allied bridgehead and its defenses. Conventional reconnaissance flights were immediately dispatched but were repeatedly shot down by the intense concentration of Allied air defenses. Only the Arado Ar-234 possessed the necessary speed to penetrate the formidable anti-aircraft screens and return safely. In the days following the capture, the Ar-234 flew repeated, fearless photographic missions over the critical bridgehead. These high-speed flights provided the only accurate, real-time intelligence for the German counterattacks and attempts to destroy the structure. The jet's photos allowed German artillery to target the bridge with some precision in their desperate attempts to collapse it. These missions over Remagen cemented the Ar-234's reputation as an untouchable spy in the eyes of both sides. The sight of the solitary jet streaking overhead became a symbol of Germany's technological desperation and its fleeting genius. While its missions could not ultimately prevent the bridge's eventual collapse or the Allied advance, they were invaluable at the time. The reimagined flights serve as the ultimate historical testament to the jet's superior speed and unmatched reconnaissance capability. The initial dismissiveness of Allied Air Command quickly transformed into a genuine and profound concern. Pilots who had flown unchallenged for years now reported encounters with an enemy that simply could not be caught. These reports described a fast, twin-engine aircraft that would appear high overhead, take its pictures, and vanish before interceptors could even gain altitude. The sheer frustration among the Allied fighter pilots was palpable, knowing a crucial enemy asset was operating with impunity. The appearance of the U-234 over strategic targets confirmed that the technological gap had been abruptly closed and even momentarily surpassed. Allied air defense planners were forced to re-evaluate their entire interception doctrine, which was predicated on piston engine performance. There was no Allied fighter in service that could successfully engage the U-234 on equal terms, let alone overtake it. The psychological impact of the untouchable jet bomber was perhaps more significant than its actual military destruction. It represented a profound threat to the comfortable narrative of total Allied air dominance that had been established. Fear was quickly replaced by a furious effort to capture and reverse engineer the German jet technology. The presence of the U-234 made it clear that Allied engineers needed to push their own jet programs to the forefront immediately. The days of mocking the reliability and effectiveness of German jet aircraft were officially and forever over. Despite its revolutionary performance, the Arado U-234 was heavily constrained by the realities of late-war Germany. The Junkers Jumo 00 for engines were still notoriously unreliable, possessing a short service life and requiring frequent, complex maintenance. Engine flameouts and failures, especially during critical phases of flight, were a persistent and dangerous problem for the single pilot. Fuel was a crippling concern, as Germany's synthetic fuel production was constantly targeted and depleted by Allied bombers. The jet's voracious fuel consumption meant missions were often limited in duration and range, restricting its strategic reach. The initial trolley and skid landing gear system, while innovative, made ground handling cumbersome and required well-prepared airfields. Later conventional gear improved mobility but added weight, slightly reducing the jet's maximum potential speed. The lack of specialized training for jet mechanics and pilots meant that operational readiness was frequently below required levels. Only a small number of the aircraft were ever produced, with estimates ranging from less than 200 total airframes. This low production volume ensured the U-234 remained a tactical nuisance rather than a strategic game-changer. The aircraft's brilliant design was ultimately overwhelmed and neutralized not by Allied fighters, but by the collapse of the German war economy. It was a technological marvel that arrived far too late and in far too few numbers to affect the final outcome of the conflict. The Arado U-234, though a footnote in the grand scale of World War II, left an indelible mark on aviation history. It stands today as the undisputed world's first jet-powered bomber and the progenitor of all jet-powered reconnaissance aircraft. Its design principles, including the clean wing, twin-engine configuration, and high-speed envelope, influenced post-war aircraft design across the globe. Immediately after the war, captured U-234 airframes were intensely studied by both American and British engineers. They provided invaluable technical insights into high-speed flight, jet engine installation, and aerodynamic efficiency. The lessons learned from the Arado contributed directly to the rapid advancement of the burgeoning American and British jet programs. The United States Air Force, in particular, utilized many of the concepts in the development of their own early jet reconnaissance platforms. Engineers marveled at the simplicity and performance of the Arado's uncompromised, speed-focused structural design. The R-234 proved beyond any doubt that jet propulsion was the future for both military and civilian aviation. It validated the strategic concept of the high-speed, high-altitude photographic platform operating with virtual immunity. Its very existence served as a final, dramatic demonstration of the revolutionary power of jet technology. The aircraft became a powerful symbol of German engineering prowess, even in the face of catastrophic military failure. The jet age was not ushered in by a single, decisive battle but by a series of technological leaps and acknowledgements. The Arado R-234 was the undeniable proof of concept that ultimately forced the global aviation industry to abandon propellers. Its operational performance during World War II initiated a frantic race among the victorious Allies to catch up and then surpass its speed. The Korean War just a few years later would see the skies dominated entirely by jet fighters, validating the transition. Modern air travel, long-range reconnaissance, and high-altitude bombing all owe a direct debt to this revolutionary German design. Today, every major air force operates entirely jet-powered combat and surveillance fleets that can fly faster than the speed of sound. The ease with which the R-234 evaded the most advanced Allied piston fighters illustrates a fundamental turning point in aerial design. Its legacy is visible in the sleek, twin-engine profiles of modern aircraft that streak across the global sky daily. The Allied mockery was brief, ending the moment the Arado R-234 left behind their fastest fighters in its turbulent wake. It was an aircraft born of desperation, but its impact on the century of flight was nothing short of monumental. The era of the piston engine was over, and the dazzling, deafening future of the jet had irreversibly begun.